Okay, in this presentation we are going to look at Project Euler question 9. This is really a short enough question really because we're going to use for loops and nested for loops quite a lot. We're using Jupyter notebooks and we are using Julia version 1.6.1. A Pythagorean triplet is a set of three natural numbers a, b, c, where a is less than b, less than c, for which a squared plus b squared is equal to c squared. Okay. For example, 3 squared plus 4 squared equals 9 plus 16. That's equal to 25, and that is equal to 5 squared. So 3, 4, and 5 are a Pythagorean triplet. Okay. There exists exactly one Pythagorean triplet for which a plus b plus c is equal to 1000. So essentially what we have to do is find a, b, and c and find the product of those three numbers. So what I'm going to do here is use a for loop approach. I'll just talk about that shortly. So we're just going to use two functions to help us with these constraints. Function is triple, just checks that a squared plus b squared is equal to c squared. So that function will return true or false depending on whether or not they are a triple. Also, what we're going to do here is have another function there, sum 1000, a, b, c, and that just checks if the sum of those numbers is 1000. Okay, so we're going to set up a function here called Euler 9. Okay, it's a nested for loop, and we got three iterators, I, j, and k. Okay, now just actually notice that the range of I is 1 to 1000, but the range of j is I to 1000, and the range of k is j to 1000. Okay, that's essentially to prevent duplication. Okay, to stop us checking the same set of numbers three times in a row. So it just sort of speeds things up a little bit. That requires a little bit of lateral thinking as to why the iterators are like that. But essentially, the I, J, and K, the triplet does not require any order really. We just need three numbers that give us a triplet, and then the the product is or the sum will be 1000 and so on. Okay. Now I think if you sort of start practicing with the nested for loops like that, you'll find that essentially I is or j k is always going to be bigger than j for mostly. Okay, and j and k are going to be greater than I. So it sort of helps the ordering there as well. Okay, so probably a bit of a time spent with those nested for loops. Now, what we're going to do here is use our two if statements there with our logical conditions. Our logical tests is triple, okay, and is sum, okay. So essentially, we know that there's only going to be one of these. So essentially what it does, it just keeps searching for each of the three numbers, through each of the three numbers, I, j, and k, and it carries out these two tests, and if it passes both of the tests, we got our triplet and we got our product. So a nice straightforward approach here. Okay, and let's run that. Is triple is not defined. Silly me because I forgot to run this. Just be careful with Jupyter notebooks like that. So there we go. 200, 375, 425. And the answer there is this number here. It is 31,875,000. Okay. That's good. Now, but what I'm going to do here is actually just see if we can improve our skill set a bit. Let's look at other approaches here. Okay. So what I'm going to use here is a function in a package called Quanticon. Okay. And there's a package here called GridMake, and I really like this. Now, I'm not sure how useful this is going to be really in practice, but it's just good to know what we can use other approaches and what we can do with them. Okay, so I have a package here and it's called GridMake, and essentially what this does, it makes up a combination of each of these and each of these. It's a sort of essentially a Cartesian product, if you will. Okay, so for each item in the first one, we pair it with each item in the second argument, the second vector. Okay, so it creates a Cartesian product. This is called grid make. Okay, and I like this one a lot. Now, I'm going to skip that actually. So I had an idea to use data frames for this, but that'll just take too long. So I'm just going to sort of skip that. That's an interesting approach here, working with data frames. I had it in mind, but then I'm thinking just this will take too long. So what I'm going to do here is create grid make, and I'm going to create an array out of that, and it has each combination of, or each number from 1 to 199. Okay, I'm just being a bit more smart there about the indices. Okay, there we go. And so on. Okay, so what I'm going to do here is just let a equal to 1, the first column. Okay, now there's 998 or 998,001 items in that. Okay, but that contains every single combination of it. That array there has every single combination of A and B. Okay. Now, previously I said that we can use the fact that C is equal to A plus is equal to 1000 minus A plus B. Okay, that's something we're going to use here because that just cuts down a lot of the overhead there. We don't really need to know what C is really. Okay, we just need two numbers and we can deduce what C is from that. And the product is something we're looking for. Okay, so I'm just going to call this D. So essentially what I'm going to do is going to create a vector, or matrix actually, using all of those A, B, C, and D. Okay, so I'm going to concatenate them, cat, okay, using along the columns, 2, 2, 2, 2, that's the column dimension. Okay, let's run that, have a look at that. And I forget to run, there we go. So D is the product. Now, the thing about this is that right now it allows C to be negative, and that means the product to be negative. So what we're going to do there is subset it. By the way, there's another command there called hcat, which is horizontal concatenation. Okay, and that's for columns. There's one for vcat if you're trying to concatenate along rows. Okay, now what we want here is a squared b squared. A squared plus b squared. So I'm just going to create this little array, okay, where a squared plus b based on a squared plus b squared, and likewise c2, which is c squared. So essentially what we want to do is find all where a2 b2, which is the sum of the squares, equals c squared. Okay, so that checks true all of these. Okay, a squared plus b squared. So essentially, just creates another array, and we just want to see where the arrays have equal value, a2, b2, and c2. Okay, and we find the indices for that. Okay, so find all, and this is a logical condition here, and just remember that little dot there because it's two vectors. Okay, so this gives us our indices, okay, of where a squared and b squared will equal to c squared. Okay, we've already defined c such that it is a plus b plus c is equal to 1000. So there we go. That's just a different approach to doing it. Okay, it's probably not as good actually as the nested for loop approach, but I think it's just actually good to actually try as many different approaches as possible. And also, this grid make thing here could be very handy in other circumstances. So that is from the quant econ package. All right.